Okay, for part G, you're told sound travels through air at a speed of 340 meters per second. And then you're asked to find the wavelength of the sound. So notice that wavelength is what you're looking for. Well, on the quiz, a lot of folks were hung up on the fact that the definition for wavelength is the length of one wave. So it's the length divided by the number of waves. But that actually doesn't take advantage of what they're actually giving you. What they're giving you in this problem is the 340 meters per second, which is actually the speed. So notice that they're giving you speed, and they want the wavelength. So on the quiz, what you need to do is go to the board and look for an equation that has what they're giving you and what you want. The only one on the board that has what you want, or has what you want and has what you're given, is this one. Speed equals to frequency times wavelength. So we know we have to use this equation, and so I'm just going to plug in what we have. We're given speed, and we know what we want. We want wavelength, so I'm going to rewrite that as lambda. Okay. I know I have speed, and I'm looking for lambda, which means that I actually need the frequency. I need to know what this is. And a lot of us paused there and just didn't know what to do. Well, remember that this is a quiz that has multiple parts. So you actually need to go somewhere else to find the frequency. So did this question talk about frequency? No, it talks about amplitude and talks about energy. And does this question talk about frequency? No, it talks about longitudinal waves, how it's parallel. This question is giving us the amplitude. This question is giving the frequency. Okay, so we actually have solved for the frequency a while back. We know the frequency is actually 429 hertz. And so during your quiz, you have to keep track of these things and remember what you have solved. And we have solved for 429 for the frequency, which we needed to use on this problem, and we actually need to use it for this problem as well. So for this problem, we're going to plug in the frequency that we found, 429, times the wavelength, which we don't know what the wavelength is. Okay, so this just becomes a normal algebra problem. You have 340 equals to 429 times some number, which I know for a math class, you're more used to seeing this as 340 equals to 420 times x. Because x is just some number, which is what we have here. We want some number times 429 equals to 340. These two things are exactly the same thing. We're solving for x here, we're solving for wavelength here, which means the same thing. So over here, we all know we're supposed to divide this number on both sides so that we can get rid of the 429. And we get x equals to whatever this is. So same thing for this problem. We just have to divide away the 429 on both sides so that we can get this to cancel out. And so we're left with 340 divided by 429. That should give you 0.7925. So x and wavelength is 0.79. So my answer is wavelength is 0.79. Now, in order to get full credit, you have to absolutely include the right units. So in order to find the right units, you have to know what units they're already giving you. Notice that the only thing here, and the hidden thing is 429 is hertz, If I want wavelength, I need a length. And the only thing here that has anything to do with length is the meters right here. So the units for wavelength in this problem will be meters. Meters is not always the units for wavelength, but in this case, because it's meters per second, that becomes your wavelength.